Okay, so we're back showing our latest DisplayLink solutions. Here we have DisplayLink's DL-7000 series. This is our Navarro chipset. This is the latest to market. But what I'd like to highlight here is that you'll see we've also highlighted this as GPU agnostic docking. Now, the reason for this is actually very clear. A lot of people have utilized the term universal. And so consequently now it's a little bit confusing as to what does that actually mean. The reality of our GPU solutions with DisplayLink is that what we're doing is we're creating a software or virtual graphics card. That graphics card presents itself to the operating system separate from the GPU. So we're not bound to any kind of limitation that may come with the inbuilt systems of a notebook or a PC. If you think about a lot of platforms today, if you want to expand to 3 or 4 displays, you have to shut the lid of the laptop. And that's because it can only drive so many at one particular time. Here we bypass all of that. It's GPU agnostic because it doesn't matter. That means you get a longer ROI in terms of the notebook capability, and it also means you've got extended capability in terms of displays that you can connect out. So here you'll see we're driving 4 at one particular point in time. All of these 4 concurrently connecting, these are all driven 4K. These are 4K P60.
Just by one Type-C.
Just by one Type-C.
So this is totally next gen of DisplayLink.
This is the next generation of DisplayLink, the 7000 series, and that's integrated into this docking station right here. Now,
what was the limit before?
So previously we had architectures that allowed for 2 displays to be connected. Now you could daisy chain them. Always our solutions have had the capability with our compression algorithms to be able to daisy chain. But here we've taken it a stage further. So 2 wasn't enough for a lot of people. People wanted 3. We've gone to 4 to give it that extensibility. But at the same point in time, even though we're 4 here, we can still daisy chain. So we can still expand it further.
Is it a very smart compression technology or to higher bandwidth than before?
That's a great question. So the compression that we've got with DisplayLink operates on a dynamic basis. So we're constantly looking at what's happening on the bus and we're dynamically adjusting. It's not a binary on or off or only 2 levels. We can jump in and out of hundreds of different levels of compression based on what's happening in real time on the bus. And really what that's delivering is the very best user experience out to the end user. And that's really what matters.
There's so many things on the screen here.
This is a snapshot of performance improvements over our previous generation. So this really takes it up a huge level.
So I see 8 cores. Your chip is 8 cores.
Yes, that's correct. That's correct.
And I see 10K. That's a lot of Ks.
Yes, that's huge.
Yeah.
So 4K for the last few years, right, has been huge. We're capable of 8K. We're also capable of 10K. If you think about it, 4K, that's 8K already. So we're actually we're kind of proving the capabilities to be able to drive 8K right now.
So you can do even a little bit more than 4K,
yes, maybe. Yes, absolutely. Now, whilst this is exciting, what I'd like to show you is something else. And I've got my colleague here, Alban, because
Hello.
You're used to seeing the notebook as the host. What we're going to do is change things up a little bit and not just have the notebook as the host, but give some benefits that could go to IT and to infrastructure people. So Alban, why don't you go ahead and introduce that?
Okay, so hello. So now I'm going to disconnect the product from the computer. So now the computer is not involved at all in what we're going to see. This is from the docking station itself. The dock has taken over the displays, taken over the USB ports, and controls everything. The chip that you saw before now is controlling everything. Through these screens, you can inform the user first that the screen is powered, the right input is selected, the cable is correct. So just by having a rested screen like this, you are subtly guiding the user on what to do next, which is to connect. And because the chip is able to sense connections on every port, if there's a problem at connection, we can also report status and the reason or what to do next. So we can give actionable feedback as opposed to current generations of products, we'll just give you a black screen. But here what we have is we're composing an image in the chip from different sources. So I take my background and I superimpose information. So here we've got the clock. The dock is network connected. Could be either through wired Ethernet or Wi-Fi radios. And here I just ask the time from the network.
What is a system? How do you describe this?
So I would describe it as interactive splash screens. Interactive because here I have a button, and I switch to having the detailed peripherals, and I can see at a snapshot what is connected to the dock. So you have an overview of the displays. So in this mode just now, driving at 1080p with the connector type, but also the USB devices. So this new chip acts as a USB host, a full USB host. So I can not only know what's connected, but I also can use them.
How does it know the names of these devices and stuff?
Because when you enumerate a device, the first thing a device would tell you is identification. That means both the name, the product ID, and its functionality. So you know it's a mouse. The reason why it's important to know it's a mouse is if you don't have any mouse or keyboard at a desk, it means the desk is not usable. So as opposed to now, the only way of knowing is if somebody complains, here the hardware will report it directly. I don't see a keyboard anymore. And it could be that somebody used it elsewhere, but whatever the reason, it means the desk now is unusable. And here the hardware the dock can report it automatically, so IT is notified and doesn't need to wait for a call for somebody to fix things.
Is this part of the feature requests people had for DisplayLink?
Yes.
And
yes.
they asked for this to be?
Yes, yes. Another one they ask is about asset tracking. So here I go into a monitor details information, and you can see, so I'm cycling through the different monitors, and you can see the serial number is changing. So why is it important? IT wants to track high-value assets, and monitors are high-value assets. Today, the way to do this is to go at every desk with a clipboard and look behind where's this display. And if your office is like mine, when a user leaves the company, then other users tend to go and borrow hardware. Here you will know as a snapshot where everything is in your corporation. And if you want to do renewal based on usage, like upgrade hardware, then you would know because you would know how long you've seen this hardware on your deployments. Another feature asked for, so asset tracking could be used in conjunction with the USB devices. If it's a desk for video conferencing and there's no camera or no headset, it's not usable. The other aspect is manageability. One of the headaches today is firmware. So today, if you want to update firmware, you need to go to the desk, usually with a Windows laptop and a flashing utility. This is nice if you have 1 or 2 desks to do, but if you have 10,000, you're not going to do it. So it means that users are seeing problems that were fixed years ago just because the fix was never deployed. It could also potentially open to security problems because something old was fixed and not deployed. Here, we know, I said we know the status of every port. So we know if you're connected or not to the host. But you see, we have a clock here. So I could say, well, at night, when nobody's using the dock, please update to the latest firmware agreed by the corporation.
So there's a firmware on what? On all these?
The different components. So you can update.
Dock.
Yes. These are the different components of the dock. And our SoC, it talks to all of them to be able to program them.
Can you describe a little bit more the SoC? What is this? Do you have more you want to show before we go back?
No.
Yeah.
So let's ask a question.
You had it on. Let's have the presentation again.
Yep. Okay. So the SoC I'm referring to is the DL-7000. Okay, but now I'm docked, and you see the different features of a dock. So what we have is, it's composed of, I would say, different modules, so different blocks, not just CPUs, but also video blocks, Ethernet to add connectivity, and other connectivity to be able to drive peripherals. So that's why I mentioned that this chip, I would use SoC and chip interchangeably, but this chip can talk to the other chips in the product to update them, to query them, and know if there's an error or something like that.
Are all these other chips also from Synaptics?
Not all of them. So we can do, we do video. The radio could be ours, yes. USB hubs, we don't do any USB hubs, and we don't do PD controllers. That's what charges the laptop. But we collaborate with these vendors to design the full solution, because that's a problem for them as well to update these in the field.
So you use those 8-core, can you describe, is there any ARM in there?
No, not in this chip. And the reason I would say it's not necessarily necessary is because what we do is we do an abstraction of these cores. So the user does not really program on these chips. And for the part where the manufacturer can program, we offer a higher level language like Python. So it means that we can make abstraction of a low layer of the hardware implementation.
What is this 3 × 1 gigahertz?
These are the CPUs which are dedicated for our customers' applications. So part of the 8 cores, you've got cores that are dedicated to security, video decryption, and others. But what we did is we have additional cores that are dedicated for the added value that our customers want to bring.
What is the security like? So people don't record the outputs, or?
There's this, yes. So typical encryption that you used to see in DVDs, but you also see now on Netflix and others. So that's a standard HDCP. But also the dock is talking to the laptop to exchange information. We also encrypt these discussions. You also have encryption on the Ethernet as well, because you are here. I can be cloud connected to control the dock for firmware, so you need to secure that connection. So you also have hardware accelerator for encryption.
So this works best when you have a really good USB speed. What is the speed? At least USB 3? Or
we use USB 3. So if you have USB 4 or others, it works, but we don't need it.
It's not going to increase the capacity, the capability.
No, we don't need this because we work differently. The crux of the product, the goal is to optimize the bandwidth efficiency. And what we did is, so we looked at the previous generation, 5 gig, so USB 3 standard, 3.0 was standard, so that's what we used. Here, we've seen that all the hosts now have USB 3.2, so 10 gig on every port. So it means that if you connect this to any port, it will work at full capacity.
Do you use the full 10 gig?
No, not yet, no.
So
if you were going to 8 gig, maybe, if you were also doing, so we have Ethernet at 2.5 gig, but actually the chip itself can do traffic management, so we can prioritize video over Ethernet, something other solutions that have split functionality can't do because they don't see it. We have the ability of saying, well, this video needs a bit more bandwidth, and we can throttle the less priority, the lower priority items.
For many years, I was always wondering DisplayLink codec, what it is. Is it just some kind of H.264 or something really special?
It's better. It's better. Because one of the challenges with H.264, and if you've watched Netflix, you'll see, is text has some ringing effects. It's not really legible. And when DisplayLink was created, the idea was to be just as good as the HDMI cable in the case you don't have an HDMI cable. So the algorithm, the codec is able to sense the type of content. So it's able to tweak the compression based on what the type of content it is. What I mean by this is, if it's text, it must be sharp. So you don't do much compression, and you know what it is. Video sometimes supports a bit more compression because it's moving content, and your eye is less sensitive to that. But what we can do as well is we can sense the bandwidth on the medium. So most, I would say, codec, what they do is you set them a specific speed of compression, a certain ratio, and they do this. But what we do is, if we see that they start to make contention somewhere, we can tweak the algorithm to send more or less data and clean up afterwards. One of the other also notable difference compared to other technologies is, I said we use the bandwidth efficiently, and the reason for that is Windows is very well built. It will tell us which zone of the screens have changed. So instead of sending from the computer all the time, all the pixels, if you look now at this screen, only this section of the screen changes, and just now this one, so we only need to re-encode that. So it's more efficient because we don't need to send all the pixels all the time.
It sounds so advanced. It sounds like really special. Is it like do you define? Is there a name for it? Is DisplayLink or?
It's DisplayLink, yes.
Is the DisplayLink codec?
Yes, yes. We've been working at it for, I don't know, 10, 15 years, and we keep on improving it each time. So for instance, COVID arrived and everybody was doing video conferencing, and we had feedback, well, you know, in these cases, in these use cases, you need to optimize. So we worked on this, and now we take care of video conferencing better. So it's in constant evolution at each release.
All right. So it sounds awesome. This, how much has happened like since with the Synaptics partnership now?
It's been a great partnership. When we came into this as DisplayLink, we had part of the market. Synaptics also has the alt mode capabilities. So now we have probably over 90% market share on capabilities from a video interface perspective, which is huge. Obviously, it gives us the ability to be able to combine the best of both worlds. So what we're really trying to do now is to deliver that next level of manageability, flexibility, as well as performance, right? Because it's not just about speeds and feeds. It's about the usability, what people really need to be able to use their platforms for. But at the same time, we're trying to expand things up a little bit. So the other thing we've got down here that I do want to bring your attention to is a PCI card. Now, this PCI card is also equipped with our DL-7000 series Navarro chip. Very uniquely, we're driving on the output. If I turn this around, we're driving on the output, you'll see 2 USB ports. We can drive this with 2, we can drive this with 4. So this gives the capability of not only driving something like a docking station, but also going into small form factor PCs or thin client devices. So where you'd want to deploy more graphics capability, more video connectivity, very easily, but you don't necessarily have the space or the power to be able to drive a big graphics card, you can get the flexibility from driving externally now with DisplayLink as well.
So when you say Synaptics is doing the alt mode, are you talking about DisplayPort?
DisplayPort, yes. So DisplayPort over USB, which is exactly what we have here. So just next to us is DisplayPort over USB.
Maybe we can do another video about that
so
after.
we can cover that after, yes, absolutely.
But the point is that no matter how great these new laptops become and faster and how much they might do in the alt mode, it's always useful to have also the full DisplayLink functionality also.
Well, here's what we find is the most critical element. Think about IT budgets today, they're not expanding. So the capabilities, we've always got to work within a window that we've got to be able to afford replacement hardware. Now, we'd love to get replacement hardware in the latest and greatest notebooks, but it's not always possible. So what you've got with DisplayLink is the ability to not just use the very latest generation notebooks, but previous generation notebooks and still get to this level of connectivity.
Are you kind of like boosting the GPU?
You know, we're using the GPU and the CPU, so we can load balance what we do in terms of encoding between them. And that's what our software codec has the ability to be able to utilize both the CPU and the GPU, but it's also constantly monitoring what's being used at that time. So for example, if you're using a very heavy loading GPU solution, it'll stay clear of that and do most of the encoding on the CPU because we can monitor load. So this way, it really gives you that best user experience.
But how can it run on older hardware so good?
Because we're a software engine. So being a software graphics capability, we delimit ourselves from the GPU. So you've got the capabilities that the GPU brings. We present another graphics card, effectively like a virtual graphics card, you could call it, to the operating system. So the operating system gets the ability to be able to drive the capabilities that we can using our external chips.
All right, and here I see that you say lower power. Is it also like green technology?
So one of the things we're always trying to drive as the industry does more and more focus on reducing power is to ensure that what we do is exactly match those curves, right? So what you're seeing here, this spec difference is actually from our previous generation. So from our previous generation, whilst we've boosted the cores, we've boosted the capability, we've boosted the throughput, we've doubled the amount of displays that you can connect, whilst we've done all of that, we've also reduced the power. Now this is critical today because so many companies are very focused on not spending hugely in terms of power bills and budgets. So what Navarro does is it gives you the ability to expand to all of this while still keeping the power curve low.
All right. So exciting next gen.
Very, very exciting. We're super excited by this. I think it really opens up a new market space for docking and, of course, for PCs with this.
Is there any chance that the docking could be like hybrid? Do a bunch of alt mode and DisplayLink?
Well, it's interesting you ask. We've had hybrid solutions in the market for the past 3-4 years. So we partnered with many companies even prior to the acquisition, and since the acquisition we've also put our Synaptics alt mode devices and our DisplayLink devices together in docks. So that's given you the ability, so if you've seen some of these triple head docks, for example, those triple head docks were enabled by having 2 from DisplayLink and the third one from alt mode. So yeah, all of those capabilities to get together with our portfolio today.